Hi, gents. Um, Sorry about the lack of videos. Just the last couple of days, I was just finishing off your mocks. Thankfully, they're now done. So I have handed them into Martina in school, and she's actually going to post them out to each of you individually. So I think that'll come maybe with your overall results as well. So that's that done, and we'll be able to get back now and do quite a few videos. You'll have seen that I uploaded some sample papers from Educate.ie. I think they are really fantastic. Quite honestly, a great set of papers, and they're really good to practice with. So what I'll do here is I'll maybe run through, say, the first three questions or something like that. I'll try and do paper one and paper two. I'm going to take sample paper 5, and that's the one that we will do today. Just want to just kind of speak a little bit more generally, just about your exams and stuff like that. I held off on the speculation. Obviously I was quite concerned about this well before we shut down. But just again, I don't have any insight or knowledge other than what I can see in front of me. And just in terms of you being worried, is the Leaving Cert going to go ahead? My gut instinct, and it is only a gut instinct, is that the answer will be yes, that it will go ahead. I think the disruption to colleges and schools and all the rest is just going to be huge. Now I know that there's obviously massive disruption elsewhere. My absolute best guess would be something like that they might cancel junior cert. They'd have twice the number of exam centres for you, and they could space you out nice and, well, I won't say easily, but they could certainly space you out easier than if the third years were there. That'd be a guess. We'll obviously see what the Minister for Education has to say. Really depends how things go as well over the next while. Maybe things will get very bad, in which case they won't go and do that, or maybe they'll get much better, and then they'd be able to do that, or even not cancel junior cert or something like that. But anyway, I just want to say your approach to this really should be assume that the Leaving Cert is going ahead, and assume that it's going ahead on the day that it's down for. That would be my best guess. Okay. Let's go and do this again. What I said to you the last time was, good idea is to pause the video and try these things out. Okay, maybe you already have downloaded the sample sheets there. You can maybe print them off at home, or just simply write them down on a pad, whatever it is. Okay, let's begin on question 1. Answer all 6 questions from this topic. We already know that. Question 1. Plot z equals 3 plus 4i on the Argand diagram below. So we move over 3 on the reals and a 4 there. So that is where z is. Evaluate iz. Okay, evaluate iz. Do that here. So I times z, just I times 3 plus 4i. And I think they do actually want us to write it out. So this is going to be 3i plus 4i squared. So this is going to be minus 4 plus 3i. If it was I squared times z, you can take your previous one and multiply by I if you want. Or you can also know that I squared is minus 1. So it's obviously going to be minus 3 minus 4i. You're just multiplying everything by minus 1. I to the 3z, so that is I to the 3 times 3 plus 4i. I to the 3, that's just I squared times I, it's minus I. So it's minus I times 3 plus 4i. That's going to be minus 3i minus 4i squared, also known as 4 minus 3i. And I to the 4z, well, I to the 4, you should know, is I squared times I squared, minus 1 times minus 1. It's just 1, so it's just it. So it's just, what was it? Yeah, 3 plus 4i. There you go. What are we going to do? We are going to find the angle between each plot on the arcane diagram above and find the angle between each complex number by finding the slopes of the lines joining them. Okay, they are quite specific there, because if we go and plot these, so there's Z, we know that we rotate 90 degrees anti-clockwise whenever we multiply by I. So when we go to minus 4 plus 3i, there's minus 4, there's plus 3i, that is where we are. We'll call this guy IZ. Our other one, I squared Z, minus 3 minus 4i, minus 3 minus 4i, down there. And our last one, really, because the next one is just going to be a rotation of 360, is 4 minus 3i, which is here. Okay, well, obviously, what's the angle between each of the lines, if they say that? I find the slopes of the lines joining them to the origin. Okay, so it's really asking that. That's really asking that. Well, we already know the answer to this, that to go from there to there, you're going to rotate by 90 degrees. Okay, so that's what you're looking at. But they were quite specific. They said this is using slopes. Okay, using slopes. So what do? This particular line here, we moved over 3 and we moved up 4. I know that that's 4i on the scale, but that's how much you've moved up. So what I will be saying is, I'll be saying the slope of this rise over run, we went up 4 when we moved over 3. That's that slope. This slope here going left to right. How much did we rise by? Well, we didn't. Let's do this the whole way. So we're going from IZ all the way down, and I note that I didn't give those labels, to I cubed Z. How much did we fall down? Well, we went from 3 down to minus 3, so it's rise over run, so our rise is minus 6. Our run, how much we move over? From minus 4 to 4, we moved over 8. And that, of course, is minus 3 over 4. And what I would be saying to my examiner is, if I take, I'll call it 1 slope, I'll call it 2 slopes. If I take M1 and I multiply by M2, I get 4 over 3 times minus 3 over 4. That's minus 1. Therefore, perpendicular. Therefore, angle is 90 degrees between the lines. There is another formula. If it wasn't 90, which it is, if it wasn't 90, there is a formula for getting the angle between any two lines when given the slope of both those lines. So that is something that's something that you'll be able to do even if it wasn't 90 as we went along. Okay, that was that one. Oh, okay, they actually gave you the answer essentially by giving you that. So let's see, multiplying a complex number by Z. Excuse me, I'm not technically proficient enough to know how to take that out of my videos, but there we go. An anti-clockwise rotation of 90 degrees. When you multiply by I squared, you're really multiplying by I, so doing the previous thing and just doing it again. So if one was an anti-clockwise rotation of 90 degrees, multiplying by I and I again means an anti-clockwise rotation of 90 and then 90 again. So obviously it's the exact same thing except 180 degrees. I cubed 270 and this one 360, although you could just say it isn't moving at all. And if you wanted to get silly about it, you could say, well, if you're going anti-clockwise 270, you're really going clockwise 90. I would just, keep it simple, write it in like that. Nothing wrong there. Okay, obviously I would write that out properly, but I don't have to because it's not my leaving cert, so it's all good. Solve the simultaneous equation, blah. Okay, so we notice that the first one has an x squared y squared and the bottom one doesn't. So this one just looks like our standard simultaneous equation. I'll just enlarge it here. Okay, bad things to do, well, not completely bad, but inefficient things to do would be that you want to obviously go to the easier one, that's number 2 in this case, and you want to get either x equals or y equals. Very inefficient to divide both sides by 3, you're left with something not so nice. So much more efficient with that one to say that 3x minus 7 is equal to y just by subtracting 7 from both sides. And now we go to the tricky one, we sub it in. X squared minus 2 is equal to 2y squared. Now y is 3x minus 7. We just got that from the previous line. So that's what we get from line 1. X squared minus 2 is equal to 2 amounts of, work out what this thing is first, then multiply by 2, BEMDAS, but I know it's been a while. 9x squared, let's see, what do we have here? We're going to get minus 21x, so that's minus 42x's, I think, plus 49. X squared minus 2 is equal to 18x squared minus 84x's plus 98. Okay, 0 is equal to 17x squared minus 84x, and that is plus 100. Temptation here is to go straight to the quadratic formula. Even though I'm tempted to do that at this stage, but have a little bit of faith that we'll be able to work it out. So pressure is really on when you have a video, because it gets immortalized then when you can't do it. 17x is awful and it's good at the same time, because it can only be 17x and x. So various things it could be: 1 and 100, 2 and 50, 3 and nothing, 4, 25, 5, 20, and I think pretty much it, apart from the 10 and the 10. Because it's plus 100 but it's minus 84, we at least know that both of those are there, which definitely makes life a little bit easier. So it looks to me like 50 and 2 would do it. Minus 50x is what that'll multiply out to, minus 34x's, that is our minus 84x. There we go. 17x minus 50 is 0. So we get 17x is 50, and x is equal to 50 over 17. Write it like that, don't write any horrific decimal out. It's just nicer to write it like that. So x minus 2 is 0, x is 2. There we go. Okay, that's that one. Straightforward. They could ask you one where there is a fraction, and you should practice those. You'll find one in a past paper if you go on. This B part should look familiar from the mocks. X plus 4 is a factor of that. Find k, then find all the roots when p of x equals 0. So let's just do that first thing. If your first instinct is to take x plus 4 and divide it in, that is not a good instinct. Okay, I know that is what a lot of questions are, but actually if x plus 4 is a factor, that implies that x is equal to minus 4. That's a solution. Okay, x equals minus 4 is a solution or a root, another way of saying it. So that means that if you were to sub it in, since x is minus 4, if you were to replace x with minus 4, as we're doing here, since it's a solution, it should give you an answer of 0 right there. Okay, this is minus 64. Just make sure that you got the brackets all set up. That bit's 16. What's that? Plus 88 plus 56 equals 0. Okay, so 88, 56 minus 64, that's 80. So we get 80 minus 16k is equal to 0. So 80 is equal to 16k's, and k is, that's presumably 5, which it is. Okay, we now know what k is, and now what we have is we have a cubic. So I'd go back up here, x cubed minus 5x squared minus 22x plus 56. By the way, if you had done the long division, it is still possible to get that answer out. Okay, it is possible. It's just really ugly. You don't want to do that. So what are they saying? They're saying, can you please find all the roots or all the solutions when this thing is equal to 0? Okay, so really when p of x itself is 0. If it was equal to 5 or something like that, you write 5 in, subtract 5 from both sides, you're still left with a cubic. Away you go. Okay, we actually know one of the answers. We know that x equals -4. We also know one of the factors. So in this case, it very much makes sense now to do your long division or to do your box method, or whatever you want. We'll do the box here for the sake of it. We know that it's going to be x plus 4, and we know that we're going to get an x cubed in here. We know that we're going to get 56 in there. So we get x squared here. That goes in, I think it's 16. Yep, looks to me like it's that. So we get 16x in there, and we know that we're meant to get minus 22x's. And on our other one, we have 4x squareds, and we know that we're meant to get in total minus 5x squared there. Okay, so you can say to yourself, what exactly would I have to add up? So 4x squared plus something is equal to minus 5x squared. It is of course minus 9x squared, which will give us minus 9x up there. And we can use that to check, do we have the right answer here? So we minus, now did I do that incorrectly? Maybe I did. 56 divided by 4 is 14. Let's just pretend none of that happened. Okay, so what was that, 56? Well, you know what, that is handy because there's a little double check in there. That is the point of double checking when it comes to both things. So let's go 14x is there. Okay, so we will do it based on that. So what are we saying? We're saying 14x added to something is going to give us minus 22x's. So what's our something? Minus 36x's. This looks a little bit more favorable. So we do get minus 9x out there, and of course we already had it, but we'll just double check it. Minus 9x squared, and you can see here that we're going to get plus 4x squared in total, giving us what we want. We wanted that thing there. Okay, so there we go. We have now the solution to that. It is x squared minus 9x plus 14 equals 0. X minus 2, x minus 7 pops straight out. So we have x equals 2, x equals 7. Find all the roots of it. Write in x is equal to minus 4. Okay, those are the roots. That's what you were asked for, and I would write that. If you were asked for factors, it would obviously be x plus 4, x minus 2, x minus 7. I wouldn't write it down though if they didn't ask it at the end. You know, if they ask one thing, write down that one thing, because they might think that you're just being a little bit cheeky, hedging your bets because you don't know what counts as a factor and what counts as a root. Of course you do, so put in the answer down towards the bottom there. Okay, that's that particular one there. Hopefully you did a better job of that than you did in the mocks, that you had now the instinct of, okay, if x plus 4 is a factor, x equals minus 4 is a solution. I can plug that in and just immediately get out what k is. Okay, question 3. I actually had to have a quick look at this beforehand. This is a great question. You should definitely take some time out here to try this one out, because this is just the sort of kind of tough question that they will throw in. There won't be many of these sort of tough questions, I imagine, on the Leaving Cert, but this is certainly one that could be the case. So give it a shot. Really try this out, and then come back to me. Okay, here we go. If f of x is equal to that, and f of a is 3, show that some stuff is true. So what are they giving us? They're giving us that f of a is 3. That means that when we input a into our function, so we had been inputting x, we're now inputting a. So we're going to get b to the power of a plus b to the power of minus a, and down here b to the a minus b to the minus a. And we're told that when we input a, we get 3. So this part is given to us there, and they ask us now to go and find some stuff out. There are a couple of ways to do this. I should have called that guy A, so I will. There are a couple of ways now to go and do this. Here's one particular way that you could do it. B over A plus, we call this 1 over B to the power of A. And this is B to the A minus 1 over B to the A. And it's equal to 3. You could, on the left-hand side only, because it's a fraction, multiply top and bottom by B to the power of A. Okay, you can go ahead and do that. So top line would be B to the power of A times B to the power of A. So that's B to the power of A squared. I suppose you could write it like that. And we'd have plus 1. When you multiply 1 over B to the power of A times B to the power of A, you just get 1. You get the same thing going on here. Minus 1 is equal to 3. So what exactly do we have? We have B to the 2A, that is the thing that we want, plus 1. And we have B to the 2A minus 1, that's equal to 3. So we get B to the 2A plus 1 is equal to 3 amounts of B to the 2A minus 1. If you want to, you don't have to here, but oftentimes it's nice to give it a name. Okay, if you simply call it something like that, we get P plus 1 is equal to 3 amounts of P minus 1. So we get P plus 1 is equal to 3P minus 3. So here we get 4 is equal to 2P. We get 2 is equal to P, and what was P? P was B to the 2A, and you have your answer there. Okay. It would have actually been faster to give B to the A a name maybe earlier on and gone and done that. You could certainly early on as well multiply both sides, you know, maybe at this stage here, multiply both sides by B to the A minus 1 over B to the A. That's also going to get your answer out nice and fast. So that's that. Okay, hence evaluate f of 2 to the A. We know that f when we input A, we get 3 just, you know, daft things that people might think, something like that. That does not make any sense whatsoever. Okay, let's just think about a very simple function. If f of x is equal to x squared, something like that. Okay, if I input 5, obviously we get 25. Now if I double the input, 10, it doesn't mean that the output gets doubled. Okay, it does not mean that 10 squared is 50. So it doesn't work like that. You can't just go and say something like that. What's it actually asking us to do? It's asking us to input 2A into our function, which was up there above. So it means instead of b to the power of x, x is of course 2A. It's a bit late, but we might make this just a little bit smaller. B negative. So b to the power of 2A, and it's going to be plus, and this one you can say b to the power of minus 2A. I suppose we will say that, b to the minus 2A. And down here we have b to the 2A, and it was minus b to the minus 2A. And it's asking us just to find out what is this particular thing here. So the leaving cert sometimes won't leave you with a ton of space, but we already know that b to the 2A is 2. Okay, so we can immediately say that. This thing here, we'll maybe just mention this, b to the minus 2A. What do we know? We know that a to the power of minus m is 1 over a to the m. So if we b to the minus 2A, it's 1 over, and it just becomes b to the 2A. So in this case, it's obviously just going to be 1 over 2, since b to the 2A is 2. Down here we're going to end up with 2, and it's going to be minus a half. A couple of ways that you can go about it. Generally I like to do maths down the page, but they haven't given us much space. is multiply top and bottom by 2. Even before you go adding stuff, you can just do that. So you can say 4 plus 1. Here you can say 4 minus 1. So we end up now with 5 over 3. So there's our answer. Right, this one looks quite tricky. If the solutions of log blah equals the square root of log, if the solutions to that add to 17 show that b is 2. Okay, so it's very much not clear what it is that we're doing here. I don't know what the solution is, and it's not completely clear what the plan is to start off with. But we'll figure it out. Okay, let me see. This thing here. Anytime you've got a square root, of course, might be handy to call it power of a half. Same thing over here. Okay, so I think now I can see what is going to be happening here. So you can call this the power of a half if you want, but actually it might be better just to call it this. Okay, if you have log of x to the power of a half whenever to the base b, whenever you have a power up there, you can of course say half log of x to the base b. This is one of those occasions where you have something tricky, but you've got two terms that have log x to the base b. So again, just call a name. Q is equal to, I mean, you don't have to, everything should still work out, but just watch how much easier it is just even to think about whenever you just call it that. Suddenly it becomes simple, relatively speaking. Okay, square both sides, we'll get 1/4 q squared. Be careful that you do actually do that. Is equal to q, so now you've got a quadratic. So we can say that q squared minus 4q equals 0. Multiply everything, both sides, by 4, and then subtract 4q from both sides. We get q times q minus 4 equal to 0. So we now get q is 0, or q is 4. What was q? Q was log of x to the base b equal to 0. And log of x to the base b equals 4. Worth rereading the questions. If the solution to that add up to 17, the solutions, i.e. what x is. If you can figure out what x is, there are two answers, and it is a quadratic, so there are two answers. If we take our two answers for what x is, add them together to get 17, apparently b should be 2. Well, let's look at what does this mean. If you've got log x to the base b equals 0, remember you're trying to see what power do you put onto b in order to get x, and apparently the answer is 0. So we can say from this that b to the 0 is x, and similarly on the other side, b to the power of what is going to give you x? Well, apparently the answer is 4, so b to the power of 4 is x. Those are therefore our two solutions, b to the 0 and b to the 4. So our two solutions, b to the 0, which is of course 1, plus b to the 4, well, apparently those two solutions add up to give 17. And we get 1 plus b to the 4 is 17. Subtract 1 from both sides, b to the 4 is 16. And of course, it now follows that the fourth root of 16, which is 2, is the answer. So b is 2. Very nice question there. Really good. And it's only by doing those sorts of questions that you'll have an instinct for when it's a good idea to let one thing equal to another, like give something a name and so on. I think we did that as well on our previous one up there. Yeah, b to the power of 2a is equal to p. When is that tactic good? That tactic is good whenever you've got something just a little bit complicated, and if you have two of them here, you can see that we had one there and we had one there right in the middle. If you've got two of them, it's just easier just to give it a name. Same thing happened here. We have it there, we have it there. Okay. Note that you can't do it immediately here because you've log root x to the base b, whereas the other one is just log x, the base p, albeit that the whole thing is rooted. So what you do need to do is you do need to work a little bit at it first, and these are not massively difficult things to see. You know, root x is x to the power of a half. Knowing your rules of logs, so that's a half log x to the base p, and now all of a sudden, when you just take those steps, there you go. You have two of them. You've got two of them together, and you can employ that little strategy, and then go and solve it from there. Okay, look, I will stop it there just because the video will be too long otherwise. I'll do the rest of that. I'll go 4, 5, 6 a little bit later, and then we'll go into the long questions as well. They're really important to practice. That was what we were going to be doing a lot of over the next months, and it is what we will be doing a lot of, but it's what we would have been doing in class. So just make sure, because we haven't done tons of those before this breakup, that you are practicing those along with me. Okay, gents, take care. All the best.